Everything you see, everything you touch, even you, are made of atoms. But what exactly are atoms, and why do they behave the way they do? Today, we're going on an epic journey into the microscopic world that builds our universe. Get ready to uncover the mysteries of atoms, the periodic table, chemical bonds, and even the mind-bending quantum realm. So buckle up, hit that like button, and let's dive into the fascinating world of chemistry. At the most fundamental level, everything is made of atoms. An atom consists of a dense nucleus, like the sun in a solar system, packed with positively charged protons and neutral neutrons. Surrounding this core we have negatively charged electrons, zipping around in electron clouds. But here's the twist. Electrons don't move in neat little orbits like planets. Instead, thanks to quantum mechanics, they exist in probabilistic zones called orbitals. Now, the electrons aren't just there for decoration. The outermost ones, called valence electrons, are the real MVPs of chemistry. They decide how atoms interact, forming bonds that create everything from water to skyscrapers to the air you're breathing right now. So next time you drink a glass of water, remember you're taking part in an atomic handshake that's been going on for billions of years. The periodic table isn't just a boring chart, it's the ultimate guide to understanding the universe. It arranges elements by atomic number and groups them based on their behavior. Groups or columns. Elements in the same group have the same number of valence electrons, which means they react in similar ways. That's why sodium and potassium, from group 1, both explode in water, periods or rows. Moving left to right, each element gains a proton and an electron, increasing its atomic mass and changing its properties. Helium, despite sitting with the noble gases, is a little rebel. It can't hold 8 electrons like the others but still refuses to react with anything. And transition metals? Well, they follow their own chaotic rules. We'll get back to them another day. Imagine the periodic table as a map of atomic personalities, each element with its own quirks, powers, and even explosive tendencies. When atoms join forces, they form molecules. If the atoms are the same element, you get a molecule, like oxygen gas, O2, but if they're different, you get a compound like water, H2O, which behaves nothing like hydrogen or oxygen alone. But here's a cool fact. Even with the same formula, molecules can have different structures. These are called isomers, and they can change everything. For example, graphite and diamonds are both just carbon, yet one is a brittle black powder and the other is the hardest substance on Earth. Why? Because their atoms are arranged differently. See? Chemistry isn't just about knowing formulas, it's about understanding how structure changes everything. Atoms don't just float around, they bond, but not all bonds are the same. Covalent bonds. Atoms share electrons like best friends splitting a meal. This is how water and sugar hold together. Ionic bonds. One atom straight up steals an electron from another, forming oppositely charged ions that attract like table salt. NaCl. Metallic bonds. Electrons in metals are delocalized, moving freely like a sea of electricity. This is why metals are shiny and conduct electricity. And even when atoms bond, they can still be influenced by weaker forces like hydrogen bonds, which hold water molecules together, and van der Waals forces, which let geckos climb walls. Basically, everything you touch is held together by invisible atomic forces. Wild, right? You've probably noticed that water and oil don't mix. That's because of polarity. Polar substances dissolve in polar solvents, like salt and water. Nonpolar substances dissolve in nonpolar solvents, like grease and oil. But what if you need to mix polar and nonpolar substances? That's where surfactants come in. Soap molecules have a polar head and a nonpolar tail, so they can grab onto both water and oil, breaking grease apart and washing it away. So next time you wash your hands, thank chemistry for making soap your grime-fighting superhero. Everything exists in one of 4 main states of matter. Solids, rigid and organized like ice. Liquids, loose but still connected like water. Gases, free to move anywhere like oxygen in the air. Plasma, a superheated state where electrons break free, like in the sun or neon signs. Temperature measures kinetic energy, while entropy measures disorder. As heat increases, particles move faster and become more chaotic, turning solids into liquids, then gases, and eventually plasma. Nature is basically running a massive energy experiment 24/7. Chemical reactions are nature's way of breaking and making bonds to reach a more stable state. These reactions must follow the law of conservation of mass. Matter isn't created or destroyed, just rearranged. To keep track, chemists use stoichiometry, which ensures the right amounts of reactants combine to form products. And since atoms don't all weigh the same, we use moles, which is just a fancy way of counting really tiny things. It's like baking, you need the right ingredients in the right amounts, or the whole thing flops. Some reactions need a little activation energy, a push to get going. That's why wood doesn't randomly burst into flames, but once lit, it keeps burning. And then there are catalysts, the VIP guests of chemistry. They lower activation energy, speeding up reactions without being used up themselves. Think of them like a fast pass at an amusement park. Gibbs free energy tells us whether a reaction is spontaneous. If it's negative, it'll happen on its own, like fire burning. If it's positive, it needs extra energy, like photosynthesis. So, in a way, chemistry is all about energy efficiency. From tiny atoms to explosive reactions, everything around us is chemistry in motion. We explored atoms, bonds, solubility, states of matter, and even the weirdness of quantum mechanics. If you had fun learning today, don't forget to hit that like button, subscribe for more science adventures, and drop a comment with your favorite fact from this video. Let's keep the curiosity alive. Until next time, stay curious, keep experimenting, and remember, everything is made of atoms.